Hello, and welcome to C++ Crash Course. I'm your host, Mayra Alejandra Camero. Today we're going to be talking about variable, assignment operator, namespace, cin and cout, arithmetic operator, relational operator, logical operator, conditional statement, loop statement, break, continue, array, and function. The first thing we'll be going over is variable. A variable in C++ is a name given to a memory location. It is the basic unit of storage in a program. The value stored in a variable can be changed during program execution. A variable is only a name given to a memory location. All the operations done on the variable affects that memory location. In C++, all the variables must be declared before use. We have variable declaration and variable definition. The variable declaration refers to the part where a variable is first declared or introduced before its first use. A variable definition is a part where the variable is assigned a memory location and the value. Most of the times, variable declaration and variable definition are done together. There are three types of variables based on the scope of variables in C++. We have local variables, instance variables, and static variables. A variable defined within a block or method or constructor is called local variable. Instant variables are non-static variables and are declared in a class outside any method, constructor, or block. Static variables are also known as class variables. These variables are declared similarly as instant variables. The difference is that static variables are declared using the static keyword within a class outside any method, constructor, or block. There are two different ways we can write a variable in a program. Syntax 1 shows the variables written vertically, and syntax 2 shows the variables written horizontally. The second thing we'll be going over is assignment operator. Assignment operators are used to assigning value to a variable. The left side operand of the assignment operator is a variable and the right side operand of the assignment operator is a value. The value on the right side must be of the same data type of the variable on the left side, otherwise the compiler will raise an error. There are different types of assignment operators, as you can see on this table. Equal sign is the simplest assignment operator. This operator is used to assign the value on the right to the variable on the left. The plus or equals. This operator is a combination of the plus and equals operators. This operator first adds the current value of the variable on the left to the value on the right, and then assigns the result to the variable on the left. Minus equals. This operator is a combination of the minus and equals operator. This operator first subtracts the current value of the variable on the left from the value on the right, and then assigns the result to the variable on the left. Star equals. This operator is a combination of the star and equals operators. This operator first multiplies the current value of the variable on the left to the value on the right, and then assigns the rest to the variable on the left. / equals. This operator is a combination of the / and equals operator. This operator first divides the current value of the variable on the left by the value on the right, and then assigns the result to the variable on the left. In this program, you can see that first we're assigning a value of 24 to m using the equals operator. Next, we're assigning value by adding 24 to m using the plus equals operator. Then we're assigning value by subtracting 24 from m using the minus equal operator. Assigning value by multiplying 24 to m using the star equals operator. And lastly, assigning value by dividing 24 from m using the / operator. The next thing we'll be going over is namespace. Namespaces allow us to group name entities that otherwise would have global scope into narrow scopes, giving them namespace scopes. This allows organizing the elements of programs into different logical scopes referred to by names. Basically, a namespace is a declarative region that provides a scope to the identifiers, names of the types of function, variables, and etc. inside it. The functionality of namespaces is especially useful in the case that there is a possibility that a global object or function uses the same identifier as one another, causing redefinition errors. The following thing we'll be going over is CIN and COUT. C++ comes with libraries which provides us with many ways for performing input and output. In C++, input and output is performed in the form of a sequence of bytes, or more commonly known as strings. There are 3 different types of header files available in C++. The first one, IOStream, stands for Standard Input-Output Stream. This header file contains definitions to objects like CIN or COUT. IO main IP stands for Input-Output Manipulators. The methods declared in these files are used for manipulating strings. This file contains definitions like setPrecision or setW. For fstream, this header file mainly describes the file stream. This header file is used to handle the data being read from a file as input or data being written into the file as output. The C++ cout statement is the instance of the OStream class. It is used to produce output on the standard output device, which is usually the display screen. The data needed to be displayed on the screen is inserted in the standard output stream using the insertion operator. The C++ CIN statement is the instance of the class iStream. It is used to read input from the standard input device, which is usually a keyboard. The extraction operator is used along with the object CIN for reading inputs. The extraction operator extracts the data from the above CIN, which is entered using the keyboard. As you can see in this program, we're using both cout and CIN. The computer is asking the user, "What's your name?" by using cout. And the user is going to reply using CIN. On to the next discussion, arithmetic operator. Arithmetic operators are used to perform arithmetic or mathematical operations on operands. The first 2 binary operators are addition and subtraction. The plus sign operator adds 2 operands, and for subtraction, the minus sign operator subtracts 2 operands. Next 2 binary operators are multiplication and division. The star operator multiplies 2 operands. Division. The / operator divides the first 2 operand by the second. And the last binary operator is modulus. The %sign operator returns the remainder when the first operand is divided by the second. In this program, you can see that we're demonstrating the different kinds of binary arithmetic operators. The first one we do is addition. the second one subtraction, the third one multiplication, the fourth one division, and the last one being modulus. The next thing on our agenda, relational operator. Relational operations are used for comparison of two values to understand the type of relationship a pair of numbers shares. For an example, equal, not equal, greater than, lesser than, greater than or equal to, or lesser than and equal to. Equal to operand represented as equal sign, the equal to operator checks whether the two given operands are equal or not. If so, it returns true, otherwise it returns false. Not equal to operand represented by the exclamation mark and equal sign. The not equal to operator checks whether the two given operands are equal or not. If not, it returns true, otherwise it returns false. Greater than operator represented by the insertion. The greater than operator checks whether the first operand is greater than the second operand or not. If so, it returns true, otherwise it returns false. The lesser than operator represented as the exertion. The less than operator checks whether the first operand is lesser than the second operand. If so, it returns true, otherwise it returns false. Greater than or equal to operator represented by the insertion equal sign. The greater than or equal to operator checks whether the first operand is greater than or equal to the second operand. If so, it returns true, else it returns false. The less than or equal to operator represented by insertion equal sign. The less than or equal to operator checks whether the first operand is less than or equal to the second operand. If so, it returns true, if else. In this program, we show the different relational operators. We show greater than equal to, lesser than equal to, and not equal to. Next is logical operator. In this program, we show the different logical operators. First, we show logical AND, then logical OR, and then logical NOT. The next thing we'll be discussing is conditional statement. C++ has the following conditional statements: if, else, else if, and switch. In this program, the most important point to note here is that in if, else, if, as soon as the condition is met, the corresponding set of statements get executed. Rest gets ignored. If none of the condition is met, then the statement inside else gets executed. Our next discussion is loop statement. In C++, loops come into use when we need to repeatedly execute a block of statements. There are two main types of loops. The first type is the entry-controlled loops. In this type of loops, the test condition is tested before entering the loop body. For loop and while loop are entry-controlled loops. The second type of loop is the exit control loop. In this type of loop, the test condition is tested for evaluated at the end of the loop body. Therefore, the loop body will execute at least once, irrespective of whether the test condition is true or false. A do-while loop is an exit control loop. In this flowchart, you can see that we have initialization expression, test expression, and update expression. Initialization expression is where we have to initialize the loop counter to some value. A loop is a repetition control structure which allows us to write a loop that is executed for a specific number of times. The loop enables us to perform n number of steps together in one line. In test expression, we have to test the condition. If the condition evaluates to true, then we will execute the body of loop and go to update expression. Otherwise, we will exit from the loop. In update expression, after executing the loop body, this expression increments or decrements the loop variable by some value. In this program, you can see that instead of physically typing in Mayra Alejandra Camero 10 times, I'm asking the program to do it for me by using a for loop. While loops are used in situations where we do not know the exact number of iterations of loop beforehand. The loop execution is terminated on the basis of test condition. We have already stated that a loop is mainly consisted of three statements: initialization expression, test expression, and update expression. The syntax of the three loops, for, while, and do while, mainly differs on the placement of these three statements. Instead of physically typing down my name 10 times, I am asking the program to do so while using a while loop. In do-while loops, also the loop execution is terminated on the basis of test condition. The main difference between do-while loop and while loop is in do-while loop the condition is tested at the end of the loop body. Do-while loop is exit controlled, whereas other two loops are entry controlled loops. In do-while loop, the loop body will execute at least once irrespective of test condition. In the program, the test condition is to see if I is less than 1. So here int I is equal to 2, which means that it's false. So the loop is exit and will only execute once. Last but not least, we'll be talking about array. An array is a collection of items stored in a contiguous memory locations, and elements can be accessed randomly using indices of an array. They are used to store similar type of elements, as in data type must be the same for all elements. They can be used to store collection of primitive data types such as int, float, double, or char. There are various ways in which we can declare an array. It can be done by size, initializing elements, or by size and initializing elements. As you can see here, I already assigned values to an array. I use 20, 40, 60, 80, and 100. And for my variable m, I put 0. So while my variable m is less than or equal to 4, I want the message to display my array increasing. And our last topic will be on function. Functions in C++ is a set of statements that take inputs, do some specific computation, and produces output. The idea is to put some commonly or repeatedly done tasks together and make a function so that instead of writing the same code again and again for different inputs, we can call that a function. There are different parts of a function. Return type, being the first one, is a function that may return a value. The return type is a data type of value the function returns. Some functions perform the desired operations without returning a value. In this case, the return type is the keyword void. Function name is the actual name of the function. The function name and the parameter list together constitute the function signature. Parameters are like a placeholder. When a function is evoked, you pass a value to the parameter. This value is referred to as actual parameter or argument. The parameter list refers to type, order, and the number of parameters of a function. Parameters are optional, that is, a function may contain no parameters. And last, function body. Function body contains a collection of statements that define what the function actually does. Function, you simply need to pass the required parameters function name. And if the function returns a value, then you can store a returned value. So here, as you can see in the beginning of the program, I assigned my variables. And I also asked for the computer to display what the max value is, and then later calculating that max value. For these next two topics, break and continue, I will be discussing them more in depth in the next video, so stay tuned. Please tune in to my next video where we have more in-depth discussion over break and continue plus other jumping statements.